First of all, thank you for coming to attend to this talk about multi-language pipelines with Jenkins, Docker, and friends. My name is Jorge Hidalgo. I'm a senior technology architect working in ACCENTURE technology in Spain. I'm also leading globally our Java community of practice. And with me is Julio.
Hi, my name is Julio. I also work with Jorge in Spain. I'm a technology architect. My background is mostly Java, but now I'm working in a lot of projects with different cloud platforms and with different languages.
We are also members, in my case, colleague of the Malaga Java user group. And we also want to give an honorary mention to Vicente, who is here with us, because without his work, this talk will never be possible, and also to the whole team that we have there, because at the end what we are going to speak is about our little story of transformation and a journey to discover how to do better things. So initially, when we started to work in automating work, builds, etc., we rapidly discovered that there was teams that were doing things differently, that they were successing, that they were happier. And we thought how we could export those lessons learned from these teams to the others so we can manufacture unicorns. No? So the concept of being a unicorn employee, someone who is really a master on all these technologies and pipelines and automation and cloud and etc. No? But behind this funny concept, really the idea is how we can bring the whole organization, the whole group up to speed, learning from what others are doing. So very rapidly at that moment, we realized that we needed to put some kind of a standardization in place. But it's a standardization not in the sense of having everyone doing exactly the same, because that's clearly not working, but standardization in the sense of having something which is fast to stand up, so we don't need to expend a lot of time doing things, which is predictable, so whoever is in the team, if just move teams, or if it's just learning in a new technology or whatever, feel like at home. So a sense of familiarity. So with that in mind, and also happening in different iterations, we created ADOP, the DevOps platform, which is something that we started for ourselves, and then we also share with communities. It's open source, Apache license, it's in GitHub. As a way of sharing success, one teams with another's, and also to provide an easy access to the tooling platform. So tools should not be the problem. It's what you do with them. So with this, we achieved to that initial stage of being able to deploy fast, to do things, and just look forward and focus on the important things, the automation and the delivery of value. Very quickly, ADOP is Docker-based, so everything is a Docker container in ADOP, and we have top row of the usual suspects, so popular open source tools that we tend to repeatedly use together. So we learn the good patterns of using them, what are the right plugins, the right versions, integrating all together and making it really fast. I mean, there is not really a lot of rocket science here. You can get Jenkins, you can get Sonar, you can just put them together in your machines. But when you want to fine-tune, to integrate all the things, devil is in the details. And even sometimes just finding the right combination of plugins and versions could be cumbersome. So at least we have everything already easily wrapped, easily put together, so we can just focus on the important things. So at that point, with ADOP, we were able to drive this vision of being more going to DevOps, as a way of doing things, as a way of working with teams. But still, there is a lot to do. Now the world is much more different than it was 4 or 5 years ago. And this connects, just to the point, to the title of the talk, which is right now we are not just only speaking of Java. We have many other technologies in our stacks. Our solutions are not monoliths anymore. Not necessarily means that we are doing the microservices every time. It's just that we have many other things to choose from, and we need to understand and realize that things that work in Java may not work the same in Python or in Node, and we need to find a new way of doing things. So this is a classic model of how is modern engineering, no? So agile, DevOps, modern architecture, and all the different principles that we are used to hear about, no? So what we achieve when we start a new project, we want to achieve to do all these kind of things. So here there are specifically 3 things that really caught my attention in relation with the talk. One is that we need decentralized execution. So every project, every team need to have freedom to choose what they need to. If they just need to wait for someone to bring a standardization, it's probably too late. So we need to achieve that level of decentralized execution while we remain with the concept of having automated pipelines and be, resilient decoupled architecture. So with this in mind, we came to the new, let's say, the new golden standard for doing delivery automation and DevOps, which is the 3 amigos, so Jenkins, Docker, and Kubernetes. Actually, originally when we submitted this talk, we were speaking about OpenShift, but really things have evolved so fast in all these months that we release not just OpenShift, so any Kubernetes stack. So that's why we slightly changed this, because I think that the focus is on Kubernetes wherever you like it. So what are these 3 big things providing to us? So Jenkins, the things that, we know what Jenkins, but what's different with Jenkins today? What's different is that we have pipelines as code. An elegant, simple way of defining what is the journey of a commit. From the moment the commit is merged and pushed until it is in production. What's the journey of that commit? Now we can very elegantly describe that journey as code. Docker clearly is our universal application packaging mechanism. It could be Java, it could be React, Node, it could be Python, I don't care if I can package it as a Docker application. And I can standardize the way in which I am packaging and distributing my applications. And of course, Kubernetes is the universal runtime platform. Please indulge me with the universal. No? There are other options, but if we realize what we are seeing every time, Kubernetes is really gaining the traction and our love. So Kubernetes gives me the ability to take all these applications, all these individual containers, and make really solutions which are useful. And as I mentioned before, really Kubernetes is a have it your way platform. You can have it in many different flavors. Of course, you can just have it the open source distribution and build it for you and maintain it yourself. But you can also pick from a wide range of vendors. All of them are now giving you Kubernetes stacks to manage with different options, with different capabilities, but you have the choice. And you are not locked with any of them because you are just based on Docker Kubernetes. You can run it wherever you want. So what's now the process? How we do this? So very quickly, because we want to jump into the demo, into the code, and you can see these things really how they work. But the general approach is like this. So first, you can sketch what is your exemplar pipeline in the archetypes and templates that your developers are using for building new projects, new applications. So it could be a Maven archetype, it could be Geoman. The point is that the same that you can sketch your project structure and some of the, let's say, initial files, you can also, and you should also, sketch that exemplar pipeline. So your team have something to start working, not just an empty canvas. Of course, everything is in version control. So you don't need to go to a separate tool to learn how this specific piece of software is built, verified, packaged, deployed, promoted. Everything is in version control. So you have the source, you have the test, you have the Docker file, you have the Jenkins file, everything is in the same repository. No need to look for something or from the information somewhere else. Leverage mechanism like Jenkins library to reuse common tasks. So if different teams are agreeing to what's the best way, for example, of running unit tests or running an integration test, grab that in a Jenkins library, which is just a Groovy script that you import into Jenkins, which is also in version control, and then all your pipelines can reuse the Jenkins library. So imagine the power of this mechanism. You can have hundreds of projects using the library. You change the library in version control. For example, you find an enhancement to the way you are gathering the code coverage metrics. You deliver that change into the Jenkins library, and the next time every pipeline runs, the teams, for free, will get the improvement. No need to go pipeline by pipeline applying the change. So this is very powerful to really scale up this approach. But at the same time, the teams still have all the freedom to override whatever happens. Because you can import the library, you can use functions from the library, but if you decide that you need to find a different way of deploying, in this case it's an example deploying to OpenShift, no? If I need a different way of deploying my application, I can just override that stage because I have all the freedom. So this is the tricky balance between the standardization and the freedom that we need right now. And then let the platform care of anything else. So you have the software, you have the Docker file, you have the Jenkins file. If it's a more complex application, you have your Docker Compose file or your application YAML. You have everything there, and the platform will take care of everything else. So how is standardization right now, 2018? So really standardization is no longer a very specific and very, let's say, carefully defined pipeline execution. Standardization takes the form of an agreed pipeline schema. In Java, for example, with Maven, I'm going to do things differently, like if I do it in Gradle, and completely different if I'm doing it in Python, for example. What's, in this case, connecting with Julio, no? So we are playing no good job, but good cop, bad cop, but more like Java guy, Python guy, or something like that. It's like we agreed what's the pipeline we want to execute. This is what we call behavior over tool. I don't care as an architect what tool are you using for unit test as long as you're doing unit test. And I don't care what tool are you using, for example, for running your performance test as long as you are doing performance tests. So we get to the point in which we agreed on the pipeline. We provide the standardization in terms of archetypes and Jenkins libraries, and then let the teams evolve that, contribute back with the changes, so we have this balance. So now, instead of going through the slides and describing all the process, what I'm going to do is just jump into demo time, okay? So obviously, slides are less risky, but let's take the risk, okay?
We're going to cross our fingers.
Okay, so
please cross it then with us.
Be the Wi-Fi be with us, okay? Yeah, exactly. This can be really good, incredible, or it could fail miserably. It will all depend on Wi-Fi. Just like that. So Docker is rock solid, Kubernetes is rock solid, so it's just Wi-Fi, okay? But I'm pretty confident that it will work. Okay. So what I have here is just my Jenkins build, which is just connected to my code, which is here in. No, you cannot see it.
You need to move it.
I need to move it. Pum, pum, pum. I'm going to do something better. Sorry about that. I'm going to just mirror the displays, which is going to be easier for me. Okay. So I have here my application, which is, no surprises, Spring Pet Clinic. Sorry?
Increase the command
yeah.
plus. Command plus. Yeah.
Okay. So this is Spring Pet Clinic, just like that. We have it public in GitHub, and then we will share the link so you can get and take a look around. So what we've done is just basically take the popular Spring Pet Clinic application and just make it cloud native. So we added Docker file, we added the Jenkins file, we added some configuration to the pom.xml, so all the magic will work. But basically, what I have here in this pipeline is a builder image. So I don't need anything in my machine. I don't need anything in any slave. So to build the application, I also need a Docker container, which is a schedule in Kubernetes, just like that. So in this case, I'm using Maven, because it's a Java application, which Maven automation. So just pick up the Maven image. just for the sake of time, I'm reusing a volume to store all the artifacts, so we don't need to download the internet again during the demo, okay? Some people will argue that if you want to really do very strict builds, you don't even reuse the repository. You need to know that the dependencies are still there in the internet available for you. But for the sake of the demo, we will skip that just by reusing the volume. Some environment, and this is what I was mentioning before. So we have agreed what are the common steps that we need to do for running the pipeline. So what I'm going to do is to run the pipeline. And as it is working, I'm going to explain what's happening. So this is the view in the classic Jenkins, but I think that it's probably going to look nicer here in Blue Ocean, which is the new Jenkins interface. So this is our agreed pipeline. This is the pipeline that we are expecting all the projects to follow regardless of technology. This pipeline has a number of different steps. First, which is not here explicitly, you need to prepare your environment, which is take all the dependencies that you need to build your application, download them from wherever you need it. In this case, it's not explicit because Maven is just taking care of it for me. So I don't need to care about that. Then I take that, compile the code, because it's Java. In JavaScript, for example, you will probably just minify it, uglify it, so all different steps. But we are just preparing our software to be in runnable form. And next step, we are running unit tests. Very important, in this step, we are also gathering the code coverage of this unit test, which is very important to know which parts of the code are not being exercised. And I say exercise because just because your code is being executed along the way does not mean you are testing it. But at least we get the information of what is not being tested. And I want to emphasize that. So code coverage is good to know what you are not testing, but it's not good to know what you are testing. Okay? And this is very important. So it will just take a few more seconds, and then we will start with mutation testing. Mutation testing, well, there has been talk this Java 1. We also did a talk last Java 1 about mutation testing specifically. But mutation testing basically is going to let us know whether we are actually testing anything. So it will mutate the code, and if you don't have any test failing, means that you don't have a test for that use case. So let's imagine I have a call to an external service. If I remove this call to the external service from my code, and no unit test complain about that, it's because I'm not really caring about that call to the external service. So mutation testing is the step, very important step, that will give us the information about the quality of our test. Am I testing anything? Mutation tests will do that job for us. So it's going to take a few more minutes. Mutation testing needs its time because it's going to basically make one change into the code every time, re-execute the relevant test, then make another change, re-execute the test. So it's like exercising your unit test quite a few times. Depending on your code base, it could even take hours to do. So probably you want to do that only on nightly builds. While this is running, I want to show you how this is expressed in the pipeline. So every step is a stage in Jenkins. And for every stage, I have a succession of commands that I want to execute. To compile in Maven is quite simple. Maven, clean, compile. In unit test, I'm just executing Maven test, but I am going to archive the JUnit artifacts, the reports, and also with Jacoco, I'm gathering the code coverage metric. So I want to archive those results so they are later available to SonarQube, and we will see that when we are composing the results. For mutation testing, I'm using PyTest, which is a very popular tool in Java, quite mature. And it comes with a Maven plugin, so it's very easy to execute. Just execute the code, and code coverage is just launched. What's going to happen next? So mutation is still running. So I'm going to explain. No? So what's going to happen next? I'm going to package my application. In the case of Maven, I'm using Maven package, but there is an important thing that we always need to take into consideration at this step, is that when we package our application, every configuration which is environment dependent should not be part of the package. Because if we just add to the WAR file, jar file, DLL, whatever there is, environment-specific configuration, this means that the binary artifact that I'm going to test later on is not going to be the same that I'm going to deploy into production. Because at some point, I need to strip off the development environment configuration and modify it for production. So, yeah, that could be predictable, but we are not testing the same thing we are deploying. So we should always try to rely on external configuration mechanism like Spring config or whatever. So, for example, in OpenShift, you can rely on OpenShift configuration map. So everything that is dependent on the environment should be off the binary. And in the binary, we'll have all the configuration which is not dependent. So error messages, error codes, all these kind of things. Mutation tests will still run for a couple of minutes more. So let it go. So one thing I'm going to do now at this point is, before explaining the rest of the pipeline, is that I'm going to go back to Jenkins, and I'm going to launch a second pipeline. Oh, you're mad.
Yes, you're mad.
No, I'm not mad. Because one of the things that this mechanism of using Docker and Kubernetes allow us is that I can have multiple executions of the same pipeline at the same time, because they are completely independent. Every build has all the artifacts, the test container, the builder image, everything is independent from one build to another. So if you are totally in for having feedback per commit, this is really what you need. You cannot wait until one pipeline finish for the next one to run. If your development team is making changes much faster, the platform will never stand up to that speed, and you need the speed. So it's important that your pipelines also allow concurrent parallel execution. Okay, so go back to Blue Ocean. So we can see that now we have two pipelines going on. Mutation testing will still run for a few seconds. And I'm going, at this point, to also do a Docker PS. So what's happening here? What's running? So now we have, of course, our Jenkins image. We have our SonarQube image. Also a MySQL database to store SonarQube data, which is logical. And I have two transient containers, which are Maven containers. These are the builders. They will exist only during the execution of the pipeline. And once the pipeline finishes, they will just vanish, because they are just needed for the pipeline. Okay, so how we are at time? We're okay. Okay, good. So we have the two pipelines going on. Okay, let's see. Hopefully. Okay, this is still taking. Okay, so it will need a few more time. Actually, mutation testing is the step that is taking most time of all the pipeline. Roughly speaking, the pipeline will run in 10 minutes. Probably the Docker push will need a bit more depending on the Wi-Fi, but at that point, we can just say success, and that's perfect. But okay, mutation testing should be about to finish. So let's go back to the pipeline and see what's happened next. So now that I have packaged my application, it's a WAR file or a jar file, depending on the way you are deploying the application, you just build the Docker image. In this case, I'm leveraging the Spotify plugin to build the Docker image, which is a very nice plugin that the Spotify folks have made and shared. It's open source, it's in GitHub. You just add this plugin to your pom.xml. You put the name of the container image, you put the name of your org name, for example, in the registry, and it just takes care of everything, just speaking with the Docker client, launching all the commands, and you just use Maven or the familiarity of Maven goals to also manage the Docker images. So next, we will have our Docker image built. And then we will run it for all the integrations and performance tests. So to run this container, there are a couple of things, or 3 things I want to take into consideration and I want to share with you. It's like nice hacks that we have learned along the way. First, is give your test container a known but unique name, so you can have multiple pipelines running at the same time. In our case, we just give it the name of the application with the build number. And that way, they will be different containers. Yes? Not, because every container have their own IP address. And I'm not publishing those ports outside the cluster. I don't need it. I just need that my Jenkins knows where is the application, and then I'm using Selenium. I just need Selenium to know where is my application. It's container-to-container communication. I'm not really publishing this port outside, so nobody can look at them. This is a CI build, so there is no conflict in ports. Second hack is don't forget to do to add the RM parameter, because we want that this test container vanishes at the end of the build. It just needed for the duration of the build. So just put the RM, so no, regardless of this is working fine or not, or failing, or miserably, even if Jenkins just dies, the container will be removed out of the cluster. If not, you will get quite, I mean, if you do this by hundreds, you can get a lot of rubbish in the cluster if you are not careful about that. And the third thing that we do is that we should also gather code coverage metrics of our integration tests. So I personally like a lot the information that I can get for code coverage metrics, but I'm not too, I'm really not pushy about achieving a specific percentage on code coverage, especially for unit tests. The important thing is that when you combine your unit tests and your integration tests all together, all together, they will give you something meaningful. I've seen many hours spent by teams just doing unit tests on POJOs, testing getters and setters. There is no value out of it. But look at that. They are doing because someone has said you need to achieve 80% code coverage. And as integration and gathering code coverage for integration tests is quite harder, we don't do it. We just gather unit tests, which is simpler. And we just force people to do silly unit tests just for the sake of coverage. So combine unit tests and integration test code coverage metrics. It's very simple. If you are using Jacoco, just add this to your Java OPTS, and when you launch your container, regardless if it is Tomcat, Spring Boot, Jetty, Wildfly, I don't care. It will work. And it will give you a port where you can ask the JVM, give me the information of the code coverage of my integration test. So this is really an important, something that we need to do every time. I'm speaking too much. Sorry about that. Okay, so moving a bit faster. So we run the Docker image, then we run the integration test. So for that, we are using just failsafe in Maven. We are supplying where is the Selenium hub, and we are supplying where is the application. Okay, so every build has their own application, and you can test the integration test with Selenium to the right version of the application. So you are not really making confusions on that. And of course, gather the code coverage metrics for Jacoco. To gather the information, you can see here, we just launch the Jacoco command line agent, connect to the JVM in the port that we have just opened, and just dump the information on code coverage. It's very simple, just one command, and you can see it in the Jenkins file, which is in GitHub. Next, we run the performance test. We are using this example JMeter. So very simple, we just write a test case in JMeter, and using the JMeter Maven plugin, we just execute it, and we just add here our quality gate, which is, I'm not going to, I will flag the build as unstable if there is any error, and also if there is a response time in average which is larger than I want. And this is important that we have the two, because performance tests will serve two purposes. We are testing our application under load to see if it performs well, but also to know if it performs reliably with concurrent usage. I've seen many projects just setting a threshold on response time and never looking at the percentage of error. this percentage of error, which means that probably your real-time users are having problems with the application because the application is not meant to work concurrently as it should. Exactly, but and this is a good point because these performance tests can never replace like a real-time or real usage of your application, but at least give you a very quick information of this build, and you can compare with the previous build. So you cannot take this as granted. You cannot say, okay, this performs well, it's going to perform well in production. But at least I have a measure that one container at least behaves well and can do these kind of things. And very especially, I can track the trend. It could be, but it's also a task of the team to investigate why they are flaky. Are they flaky because of the network? Probably I will need to worry in production too about the network. Is flaky because sometimes there are things that are not good, because there are latency, because there are garbage collection issues? So all these things need to be investigated. Yes, false positives may arise, but I will probably feel more relaxed if I have discarded a positive like false or not finding that bug in production. It's performance tests. They are really not deterministic, but will give you a good measure of how you are doing things.
And if you find something that is completely out of what you're expecting, you can simply run again the pipeline or run twice. Mm-hmm. And you can see, oh, really we have a problem with the network, or we have found some other problems that are not of my application. Mm-hmm. But it's in a pipeline, so it's very easy to rerun and just check it again.
Mm-hmm. It's in the source code. Everything is here. So in source test JMeter, I have here my petclean.xjmx. So I have here all the variables I need to inject. So I need to know where the host is, where the port is, what the root of the application. So everything is here, and also my my test case. So everything is self-contained. Everything in version control. No need to look somewhere else. Next step. Real performance test is quite a concept in the new digital world. When you don't know how many users do you have, where they are geographically located, or what are their patterns along the day, performance tests also need to shift. They should be different. We are not doing applications like 10 years ago that we know that we have 500 users, 8 to 5 every single day. Now, things are more difficult. In many cases, you will still run this kind of performance tests in a staging environment just to see how this performs, if you are scaling well, if your Kubernetes cluster is really doing well. But from the perspective of the developer, they need to focus on how much throughput I can get from one image, and then I can extrapolate. If I can really do 100 concurrent users here, and I have 1,000 users, I can safely say, okay, I need 10 containers. That's risky. No? And you will probably want to do real performance tests in production or in production-like, but this measure is really important. And even more important than all of that, you are doing it every single build, not just something that you do 3 months later when you are going to release something. Every single build. Okay, so well, we are great. Next, and more important than ever, we need to check for dependency vulnerability. We are leveraging a lot of open source libraries in Java, in Python, in Node.js. There is a very rich ecosystem, and we get a lot of value out of it. But with that great power comes great responsibility, and in the modern world, most, if not all, of the security vulnerabilities of our applications are not in our code, are in the external dependencies. So you need, please, always check for dependencies. Check for the vulnerabilities in those dependencies. And there are very good tools in the market, and you probably have seen a few of them in the exhibition hall. But even just for the build, if you can afford it, just use OWASP, which is free and open source. And it just runs your dependencies with the CVE database, which is updated roughly every week or something like that. So you get very prompt response of any new known vulnerability to any dependency that you have in your code. So very important. And of course, put a threshold. Don't let your application with vulnerability go into production. This is Pet Clinic, so as you can see, I have relaxed my quality gate just to make it pass, okay? But this is because it's Pet Clinic, and I'm not going to fix Pet Clinic. Actually, from the roughly 100 or so vulnerabilities, we will see that mostly all of them are in the MySQL JDBC driver. So, for the sake of demo, I don't care about that. Yes, because the CVE database is inclusive of all software known. So in CVE, you have Windows vulnerabilities, Mac OS vulnerabilities, Chrome vulnerabilities. So they have a very huge database. And of course, this database is inclusive of all the open source libraries that we love. They are also there. And very precise, okay? You can see that they have a specific vulnerability, which is Spring 3.0.4 have this vulnerability. Jump to Spring 3.1.2, whatever. So very precise recommendation of that. Finally, we run SonarQube, code inspection. Well, Wi-Fi is taking its time to push the image. This usually just takes just 1 minute to push the image. Well, no problem at all. So code inspection can be arguably discussed, and I am very interested also to know your opinions about that. Code inspection should be run earlier in the pipeline, so you get feedback. If you are really doing very nasty things with your code, I probably don't care even of running on your test or spending 5-6 minutes running mutation tests if your code is going to be not passing the gate. But the good thing that we obtain by moving code inspection with SonarQube to the end is that we set up the quality gate inclusive of all the other things that we are measuring, code coverage and the like. So if I run this at the end, I just get the benefit of getting also the quality gate with all these metrics. So this means that now, if I go to SonarQube, load the project, I can see that I have also, for example, my code coverage quality mate. I have a warning because I don't have enough coverage, okay? That could be a problem if I am not testing important test cases. But for now, it's a warning. But I have that information, and I can make that information part of the quality gate or the decision I need to take for this build to be published to a Docker registry or not. Pushing this image to a Docker registry means it's good enough to be shared with others, to be moved to staging, or even to production. So this is really a very important point in which I say, you go or not go, okay? So arguably, yes, we will get benefit of moving code inspection at the beginning, but we leave something in the past. And at least in our experience, things that don't work well if you try to do 2 code inspections into moments of the pipeline. You need to set up different quality gates, so it's not working as good as we would like, so we prefer to move it to the end. And at the same time, it's because we expect that code inspection is also done by developers in their machines, with their IDEs, with the same tools that we are using here, and also during peer reviews and pull requests, okay? So I will also, if you want then later to catch up, I will be interested to know your views about that, because this is quite controversial sometimes, where to run code inspection. Okay, this is still pushing, okay? No surprise, it's taking its time, but I think that it's going well so far, so regardless of what happened with Wi-Fi. Up to this point, I've not needed Wi-Fi for anything. Now is the moment in which I'm using Wi-Fi to push the image to the Docker registry. So that is what it's probably taking more time or even failing. What we can see is what's happening right now and see that is what it's there, it's pushing. It's just needing time, okay? So I don't care. I mean, this is working really fine, just depends on the speed of your network, but I can see here. But I want to show you, but for that I need to go to the classical interface. What are the artifacts of the build? So I can see also here the code coverage. I can see here the trend of my performance tests. Well, this is a local laptop. So if performance tests are unpredictable and non-deterministic, in my laptop they are even more unpredictable and undeterministic, because I usually do other things at the same time. No? So that's why you can see that there are all these kind of spikes. But in average, it seems to be quite good, no? So I set up that in average, this should take less than 100 milliseconds response time, so it does well. And I have here also all the information, so even if I don't want to go into SonarQube, just to get just a quite eagle view of what's happening, I can see it here, and I have here the. Well, actually, the second pipeline has catch up with Wi-Fi. So the second pipeline has also verified the application, make all the things, and it's now also trying to push the Docker image. Probably that's why it's taking much longer. But well, anyway, it's working. Okay, so this is for Java, but what's happening with Python, Julio?
Well, I really have a very long speech prepared to explain you the different discussions that Jorge and myself had during the preparation of the Python pipeline, but I have just 5 minutes, so I just want to say that Jorge wins every time.
No, please.
No.
Green balls?
Well, that's right. I win one time. That is the environment preparation step. That is one step that you have not been in the Java pipeline, but it's a pipeline that we really need for the Python Jenkins pipeline. The point here is that all this work that Maven is doing for you, taking the different libraries that you're going to use in your application, or the different libraries that you're going to use simply to prepare your environment, you have to do it manually in our Jenkins pipeline. I can show you. I think I can come. Yes. The point here is that as we start our pipeline for Java from a Java image, I start my pipeline for Python from Python as clean as possible. Okay, so here I need to get all the different requirements that I'm going to need for my pipeline in this first step. I'm going to do the same because I think that I have just 3 minutes. I'm going to run my pipeline and go to the Blue Ocean. As you can see, I had some problems with the Wi-Fi, but I think that more or less we can see that we have respect the same steps. We have the environment preparation. It's the only step that I had added to my pipeline. That is one that I really need, but we don't need in the Java pipeline. But more or less, we have respect all the different steps. But the only difference is the tool that we're going to use in each of them. For example, if I go to the mutation testing, that is right here, I'm going to use Cosmic Ray. That is a library, a Python library, just for mutation testing. Probably it's not as mature as PyTest is in Java, but it's doing basically the same. For build the Docker image, I'm going to use directly Docker. But in the Java pipeline where you're using the Spotify plugin for do this, and the integration testing, I'm going to use nose test instead of, I didn't remember the tool of the Java pipeline, Selenium, for performance test, Locus, and so on. But more or less, we have the same steps with different tools that are doing more or less the same, have the same behavior. So that's. I have 2 minutes. 2 minutes left. Okay.
No, but if there are questions, we can also.
Okay, and we can see if it's capable of finish or not. Okay. So, I don't know if you have questions about Python, about the pipeline in Java, or you're going to go deeper in some of the tools. Okay. About?
Okay.
And that's the point of Kubernetes. Okay.
I mean, the point of Kubernetes is that our universal application or runtime platform. So everything here is running on top of Kubernetes. So, yeah, because we are looking. In the recent versions of Docker, you can establish which is your orchestration layer. So in the past, you could just have Docker Swarm. In our case, we choose Kubernetes as, so it's there under the hood, but it's just Docker managing Kubernetes for us. If you remember in the slide, Docker is actually one of the providers that give you a Kubernetes orchestration. Okay, so in this case, it's simple applications, so we've not done that, but when you need to do that, your application YAML will also be part of the build. So for example, with the Spotify plugin, or with the Fabricate plugin, which is also very nice, it will just handle it for you. So if you have your Docker file and your application YAML, it will just put it together and deploy into the cluster. The point is that with different tools, so for example, in this case, Julio for Python needs to tweak a bit more with the commands. In the case of Maven, I just rely on the plugin that knows how to do things. So if there is an application YAML, it will deploy as a pod. If you just have a Docker file, it will deploy as an image. It's very opinionated, but at the same time, both Spotify and Fabricate plugins do a very good job in general for making our applications work in a very similar way to what they will do in production. The thing is that most of these details are hidden from us. As a developer, I just focus on my Docker file, my Docker compose file, or my application YAML, and the tools will just take on that. But of course, you have freedom. As you can see in Julio's example with Python, you can just put there the commands. Or even in the slides, I've shown you an example in which we were just tinkering directly with OC, the OpenShift command line tool, because we needed to control the way we were deploying that specific image.
The point here is that you have all the freedom to reuse something that you have from a library or from a plugin, or you can directly work with the tools that Docker is giving to you.
And another good thing in general is that once you have your Kubernetes cluster, it tends just to make the things work well for you. The thing that you need to manage carefully, and I want to give a piece of warning of that, is that in the past we used to manage our clusters of Jenkins slaves, no? So we needed to have builders for do the work. Now we are just using containers for doing that work. So we don't really have Jenkins slaves anymore. We just have Docker images, which are living in the Kubernetes cluster. So we also need to manage in the Kubernetes cluster what's the capacity and establish the build executor in the master to control that we are not exhausting the cluster. But really, once you have done that, Kubernetes just take care of this life cycle of the containers and its dependencies. So if a container depends on another, they work as a pod or as an application, which may have multiple pods, like for example, with a database, with a message queue, or depending on another service. So time's up.
Time's up.
So any other questions? No?
No? Oh. It's a very good topic for the
we have focused here just in the continuous integration part, which is I have a binary image or an application, runtime, deliverable, executable, whatever it is, and I say it's ready or not ready. So just up to that. But and there is many options. So for example, in our cases, we're also leveraging Kubernetes for doing the deployments. We don't need Ansible for that because we just deploy Kubernetes to the right namespace. So we have a separate name. Typically, you have a different namespace for development time and for staging time and for production time. You can control that very easily just with a few commands with kubectl and move that image, which is already in the registry, through the different steps. Okay, but we didn't want to add that complexity because that's much more dependent on every case, and it will add a lot of noise. And we wanted to focus in this part. Which is really when we are speaking about language-specific stuff. The other thing is your images. Yeah. That's the issue when you have multiple dependencies. So I build a service that relies on another service, so at some point I will probably want to run a combined integration test in staging. So you can do that with this kind of pipelines, calling other pipelines, etc. Okay, so thank you very much.
Thank you, guys.